I want to go through just a couple of quick examples of what I'll term mole conversion problems. So, for example, you've already watched the videos, at least I hope so, about what the concept of a mole is. And so, what we want to be able to do is to interconvert any unit that is coming from our definition in terms of the number of particles, molecules, or atoms that you'd have in 1 mole of a substance, and also equate it to whatever its atomic mass is. So how do you interconvert between all those going both directions? So I'm going to give you the two formulas first here, and these formulas will always be given to you on tests. So 1 mole is equal to, well, whatever the mass of the substance is, divided by its atomic weight, AW, just use that as an abbreviation, or its formula weight. And in other words, you're going to get these guys from the periodic table. This is what you just add up their atomic masses, and so that's called its atomic weight if you're just doing an individual element, or if you're doing a compound like water or something, well, then you would take their masses and you would add them up, and that's called its formula weight. It's sometimes also referred to as its molar mass. So if you ever hear the word or the phrase molar mass, that's the same thing. Okay. The second one then, of course, is the basis for the definition originally as given by Avogadro, even though he passes away before it's all calculated out. But the actual number of atoms, or again, you have to change the wording if you're going to do a compound, so molecules, and then that's going to be that Avogadro's number. So they were nice enough to name it after him, that 6.02 times 10 to the 23rd. So here's a really good chance for us to use our scientific calculators then, because we got to enter in that large number. Okay, so first let me show you the periodic table. This will be the periodic table that you all are given, of course, on tests. And I'll always just put the formulas somewhere. I'll type them up somewhere down here at the bottom. So when we take test 4 and on the final exam, you actually have an official formula sheet. You're always going to be given this, okay? So let's take a couple examples here. First off, let's say I had 12.5 grams of table salt or sodium chloride. So of course we know that formula is NaCl. Okay, so I'm going to set up my little formula then that the moles will equal the mass. So that's going to be my 12.5 grams of NaCl. And then I need to divide that by the formula weights. So of course, where do I get that? I go to my periodic table. In order to find my formula weight or molar mass, meaning, or molecular weight, I'm going to go to the periodic table and add these guys up. With all of our atomic masses, you of course can use all of the digits that are printed on the periodic table. So like for example, on sodium, on your periodic table, it gives the atomic mass as 22.989770. Oh my gosh, all that, okay. I will typically use the atomic masses and I'll round them off to say 3 or 4 sig figs. So when will I do 4 sig figs? I would then say 22.99 atomic mass units is good enough for sodiums, okay. And then for chlorine, see officially on the periodic table it says our periodic table that we're using 35.4527. Nah, I can just do 4 sig figs, so let's just do 35.45, okay? All right, so then I'm going to add these guys up, and I'm going to do it live here while I'm talking, so that way you can work it through with me, confirm that you can get your calculator to do the same thing. I have 58.44. So that's going to represent the formula weight. In other words, if I had the molecular formula of a substance, I just add up their atomic masses. That's how many grams. See, here's the beauty of the mole. This is the grams if you had 1 mole. Well, in my example, we only have 12.5. So hopefully it's already apparent that we had better come out with an answer that is less than 1, because it's going to take 58.44 grams of table salt, sodium chloride, to make up 1 mole. And I just made up a number and said, oh, okay, well, what if we had 12.5? All right, so I'll plug that number in up here. So this will be my 58.44, and now see I'm going to change. I'm not going to put atomic mass units. I'm going to say grams per mole, because that's what the definition of a mole is, grams per mole. See how that the units then for the grams are going to cancel, and I indeed will be left with moles. Okay, so 12.5 divided by 58.44. I'm only allowed 3 sig figs because of the 12.5. So that's going to be 0.214 moles of NaCl. And notice how sometimes we abbreviate mole, MOL, as if it were exhausting to put the E on the end, but that's okay. All right. So that's an example of going from grams to moles. What if I wanted to go the other direction? It's no biggie. You're just going to use the same formula. So say this time I say, what if we have 2.75 moles of water? Okay, so first I'm going to go ahead and and then we want to find out how many grams that is. Okay, so first off, I'm going to go ahead and tell you that the formula weight for water is 18.02, and I'll go ahead and express it in terms of grams per mole. That's the definition. It would be that many grams if I had 1 mole. I'll let you see if you can figure out how I got the 18.02. So do the same thing as I did on the previous question where I took their atomic masses and added them up. Okay, so this time we're going to, let me see if I can write that a little neater. Now we're going to take 2.75 moles, that's going to equal then the mass, divided by the atomic weight, or the molecular weight, 18.02 grams per mole. And so I'm just solving for the different variables. So sort of like we're doing those density. Remember how density was always equal to mass divided by volume? It's the same thing here. You have one thing equal to then two things being divided by one another. So we're just solving just like we're doing a density calculation again, only now we're just putting in different kinds of numbers. Okay, 3 sig figs on this guy as well, so this is going to be 49.6, and then note my units will be grams. Hopefully an answer that comes out to be close to 50 makes sense to you, because look how that it's not quite 20 grams that makes up 1 mole of water, so that if we have close to 3 moles, I mean just shy of 3 moles, that'd be, something less than 60. Well, okay, a lot less than 60. It's all the way down to 50. Well, that should make sense then, that at least we know that we're in the right ballpark. Okay, last but not least, what if you had the number of atoms or the number of molecules and you wanted to figure out how many moles that is? So let me just make up a number here as well. Again, what if I say 2.56 times 10 to the 19th atoms of hydrogen, say? How many moles is that? Maybe that'll be the question that we'd be interested in finding out, how many moles that is. Okay, so here you're just going to use the same formula that I gave you first, only now we switch and use the Avogadro's formula. So just think in terms of any time that it has to do with grams, anything that has to do with grams, mass, that kind of stuff, then it's going to be using the atomic masses from the periodic table. If it has anything to do with the actual particles, like somebody counting them out somehow, if you could have a pair of tweezers that would be small enough that you could count out the individual atoms or molecules, then you're counting things, like counting out a dozen eggs or a dozen cookies, then you're going to use this formula that has Avogadro's number. Okay, so I'll plug this into my calculator. 6.02 times 10 to the 23rd. Got 3 sig figs here, so this is going to be 4.25. And then that's 10 times 10 to the negative 5th, and then that will be left with moles. My atom units will cancel, just in case you're seeing cancellation of units or how that happens. So I'm going to end up with an answer that is really, really small. 4.025 times 10 to the minus 5, that's really 0.000425. So a really small number. Well, yeah, because I was only on the order of 10 to the 19th power number of atoms, but it takes 10 to the 23rd, so that's a long ways away from having the number of atoms required to make a mole. We can go, just like in the gram calculation, go the other direction. So, for example, what if we already know the moles, in other words? So what if I had 1.35 moles of water? Make that a 2, okay, and I'm interested in finding out how many molecules. See how I changed, I don't call it atoms because now this is a compound, it's more than one type of atom, so I got to call it a molecule. Notice how, though, that the formula is the same as before, and I don't do anything different. I can't get my pen to work. In terms of what I plug in. Now I'm solving, if you want to call that your X, I'm solving for the number of molecules of water, that's the number on top. But notice, it doesn't matter if it were atoms or molecules, it's the same thing. Just like you don't use a different number if you want to figure out how many donuts you have in a dozen donuts, and then if you switch to having a dozen eggs, you don't use a different number. It's 12 for both of them. Same thing here, whether it's a molecule or an atom. If it's an element versus a compound, same thing, molecules per mole. Okay, and then I just solve for x, and so I'm multiplying those two guys together. And I got 3 sig figs, so this is going to be 8.13, that's a decimal point, times 10 to the 23rd. Well, my stylus is having some problems today. 23 molecules of water. Okay, and so that should make sense that we're getting a number that is larger than 6.02 times 10 to the 23rd. I mean, not by much, right? 6.02 versus 8.13. But that's because we have just a little bit more than 1 mole. We started with 1.35 moles. Okay, last but not least then, most complicated type of a calculation is what if you started off or finished with, doesn't matter which way, grams or atoms and wanted to convert to the other. In other words, it's not going to ask you for the moles or start with the moles. It's going to say something like this. If I had, say, 25 grams of water, how many molecules that is? Well, so see, we don't have a conversion. We don't have a formula that goes directly in between mass and molecules or mass and atoms. But what we would do is just use our strategy here for that I can go from grams to moles, and then I can go from moles to molecules. Okay? So there isn't a conversion, and it doesn't matter which way you go. You could go backwards on this as well, like maybe I'd start with molecules and go backwards to grams. You can go in all directions, it's just that you can't go directly in between them, okay? For this conversion here then, remember, it has to do with grams. That means you're doing either a formula weight or an atomic weight. And then in between moles and molecules or atoms, then remember that's that Avogadro's number. And it doesn't matter what the substance is or what the chemical is, it's always going to be the same, okay? All right, so let's try one. Or we got our 25 grams. All right, so what I would do first is take my grams and use the formula that has to do with grams. So that's going to be the first formula where you take it and divide it by its formula weight. So 25 divided by 18.02. Got 3 sig figs. That's going to be 1.39 moles of water. Then I take that and plug it into the second formula. And so then I'm going to be solving, like my x, that's going to be the number of molecules. I'm trying to solve for the number of molecules of water. And so that's going to be then plugging in that Avogadro's number. That's molecules per mole. So I'm just multiplying those guys together. So 1.39 times 6.02 times 10 to the 23rd, 3 sig figs, 8.37. Oops, that's a 3. Looks like a 5. 8.37 times 10 to the 23rd molecules. Okay, so you've got some practice problems on D2L to try of all these types. And this last type here where you have to, first go to the mole from whatever you start with and then go from the mole to whatever is being asked when you have to have those 2 steps where you're using both formulas, where you're solving for the moles and then you're plugging it into another formula. Those are on the second page in number 7. You have some examples of those.